Orb weaving spiders construct their webs by starting with straight threads that come together in a center. Then they spin spiral strands around these straight ones, rotating in ever wider orbits. Basket weavers work in a similarly dinergic pattern. First, a number of firm strands the warp are bound together at one point, which shall become the center of the basket. Then flexible strands the weft are passed over and under the warp strands in a rotating fashion, in coil binding a firm but flexible coil takes the place of the straight warp, and it is sewn together along a gradient lines within weft material threaded through a needle because of the dynamic nature of the work process. One can easily reconstruct basket outlines the same way we reconstructed leaf outlines and the spirals of the sunflower and daisy to basket tree. Hats woven by American Indian people of the Pacific Northwest have been reconstructed. Redid the shaded triangle, show successive stages of the dinergic work process, as they indicated successive stages of growth in the plant. The centers of the two spirals that make up the curved outline are not located at random in shape. These centers coincide with the center of the hash brown in shape. They are at golden section points within two squares over the hat, identical with the two squares that enclose the hat itself. One might be tempted to attribute such hit in order to chance, but the frequency of such chance order is extraordinary. 14 samples of such hats were measured in the Thomas Burke Memorial Museum of the University of Washington. 8 of the concave type A and 6 of the convex type B, and all show in varying degrees and in different ways close approximations to the proportions of the golden section and to the Pythagorean triangles proportions corresponding to the musical harmonies of fifth diapent and fourth diatessaven, respectively. The proportional pattern of the concave hats woven out of cedar bark and bear grass by Maca Indian women and common among other Lupa people shows further variations of golden energy. Figure 2-4 demonstrates 4 of these relationships. For each of the 8 type A hats measured the proportional relation of neighboring parts A and B, it was tabulated. The closeness of these proportions to those of the golden section is again demonstrated by classical golden section constructions around the shapes. The differences between actual and theoretically exact logarithmic ratios are so small they had to be exaggerated to be visible. Figure 25 shows 2 typical examples of the convex type B have woven out of spruce and popular with Tingley, Hyder, and Conclusion. 3 of these types were measured. The shallow hats tend to approximate golden proportions, and the tall ones tend to show the 3-4 proportions of the Pythagorean triangle. This can be seen from the dash dot to Lines connecting opposite ends of the top and bottom diameters in each shallow. Type these lines coincide with the diagonals of a golden rectangle, while in the tall ones they are identical with the longest side hypotenuse of the Pythagorean triangle. The accuracy of these proportions can be appreciated from the tabulation and diagram, as well as from reconstruction of the golden section above the shallow hat to make the harmonies of these patterns more visible. These two shapes are also shown in their correspondence to the pentagonal star, the taller shape fitting neatly into the Pythagorean triangles within the central pentagon, and the shallow shapes aligning with the triangles at the tips of the pentagram. The lines of these that suggest the sinuous energy of the rondo, as well as the graceful curves of flower and leaf outlines. These harmonious and dynergic proportions emerge as naturally from the hands of these pre-later with basket weavers, as bows bend and plants grow in basket weaving is not the only craft for which this holds true. Warp and woof, the weaving of fabrics is.